Alright, so today we're going to move on with substitution. And again, I want to review a little bit about what it is. And again, you'll see here is two equations with two unknowns, x and y. So we have two linear equations. And there is going to be often one place where these two intersect. And I have made a situation here where I have two things. I have line L and line W. I thought line L could stand for levee, and line W could stand for water. So the levee, they decide to start building up at time 0. It's 2 feet tall, and the water was 1 foot up the levee then, and at 4 hours later they're the same, and then the water overcomes the levee. Those are the type of things we can do. We can figure out how fast we can build. We can do this, and we're used to this equation. We can see that we have an equation here, which I will call always the top line A, and we have a bottom one. In this case, we have line B, and it's a line because x and y are in the equation. There's an equal sign, and there's x and y. Well, we know x is equivalent to all that stuff. So hopefully we're used to the idea, and I'll move this down, that I can take the top equation here, in negative 3x plus 4y, and plug in what's equivalent to x in this case, 2y minus 4. And I can go through the steps, and if you need to, you can pause here. But you should see that I come down to y equals 4. I plug 4 back into equation B, and I get x equals 4 in this case, 4 comma 4. Two methods. We could graph them every single time, solve for y. It's a lot of work. Or we can substitute, and we're going to learn a third method later on. So when I look at this, this is the old method. Now, here's the new method. Again, are these things we can solve? I have two equations, 1, 2, xy, power is 1, so I have two first order equations, which I'll call A and B. And again, the big thing here is deciding, well, can I substitute? And I want you to notice right away that there's just an x here in the second equation. If I solve for x, I can make this equation look like the first board we just had. And I can do that. I can add 2y to both sides on the bottom equation. And b then becomes x equals 2y minus 4. And I'm going to call this, maybe I'll call it b prime. And the great thing now, especially with the erase board, I can say, hey, I'm just going to cross this out and say, hey, I have equation A and equation B. Now, if you guys are real astute or you want to rewind 60 seconds, I think you're going to see that A and B here are identical to A and B here. And once you get to this point, it's simply this methodology. But making the decision what to solve for is really important. So we could solve this. It'll go down to 4, 4. So let's try a different problem. If you want to see this again, rewind and look at the other one. If I look at the equation up here, and I have A and B, equation A and equation B. Now, I look at this, and I say 4x minus 3y equals 16 is equation B. And I look at the top one, 2x minus y equals 10. And I say to myself, hey, this is a single variable. It's negative, but I can solve the top equation for y easier, not have any equations. So I'm going to solve A for y. So I'm going to move the 2x to the other side by subtracting 2x. Negative y equals negative 2x plus 10. I'm going to divide all three terms on both sides by the negative 1 so I can make y positive, and this is one of the big errors. So I get 2x minus 10. Well, now I have what I'll call A prime. Well, now I have B. Well, alright then. And I see here I have B. I can put A prime to B. I know y is equivalent to 2x minus 10. So 3y, I can put in 2x minus 10. And the beauty now is B, when you put in A prime, becomes all one variable. I get 4x minus 6x plus 30 equals 16. This becomes negative 2x. I'm going to subtract 30 from both sides at the same time. Combine the like terms here. Negative 2x equals negative 14. Well, obviously x has to be 7. Divide both sides by negative 2. Now, I can put 7 back into A or B or in for A prime. And A prime is usually the easiest because I've solved for the other variables. So I'll do that, A prime. Y equals 2 times 7 minus 10. 14 minus 10, I get y is 4. So the solution to this set of equations is 7, 4. And I can check this. I can check 7, 4. And I don't want to check it into A or A prime because I use that to find the solution, but I can check it in B. So I'm going to do a check. 7, 4 into B. So it was 4 times x, so 4 times 7 minus 3 times y, which is 4, equals 16. And the million-dollar question is 28 minus 12 equivalent to 16? And the answer is yeah. And that way you never have to make a mistake. Now, every time we do this, the first step is to decide what do you solve for. So again, I have an ordered 2 equations, 2 unknowns. 2 equations, 2 unknowns. Do I solve the top equation or the bottom equation, and do I solve for x and y? I don't want to, when I look at this, I don't want to solve the bottom equation. I have coefficients of 2 and 3. When I see the top, I say, hey, I can solve for x pretty easy. I can move 3y to the other side. And if I add 3y to both sides, I can do it right here underneath probably. I can say, hey, I got a prime becomes x equals, these cancel, and I get 3y minus 7. And again, now it looks like equations we've done before. I'll cross off the old a. If you guys see that step again, just rewind it. But now I can say, hey, I got a. Let's put a prime because it has a variable into b. And I had 2 times x minus 3y equals 4. But now x is equivalent to what? Well, it's equivalent to 3y minus 7. I can always replace an equivalency. 4 is 2 plus 2. 4 is 3 plus 1. I can replace those. They're the same. X is 3y minus 7 this time. And I end up with 6y minus 14 minus 3y equals 4. I'm going to add 14 to both sides. And I'm going to combine the like terms. And I'm going to get 3y equals 18. So y has to be, we know 3 times blank equals 18. We know it's 6. The other option is divide both sides by 3, right? And it is 6. 18 divided by 3. So now I'm going to plug this in, and just for fun, I'm going to plug this in. Instead of plugging in a prime, I'm going to plug it into b. So I have y equals 6. Equation b. 2x minus 3 times 6 equals 4. That's 18, so I'm going to add 18 to both sides. I'm going to get 2x equals 22. Well, again, divide it both sides by 2 this time. We get x is 11. So my ordered pair is 11 comma 6. Well, if I want to check this, I use b to find it this time. I'm going to have to use a or a prime. I'll use a prime. Checking a prime this time. So I get 11 equals 3 times 6 minus 7. 18 minus 7. Is that 11? Sure is. Boom. And I have just proven that answer. Again, lots of work, takes lots of practice. Alright? Hardest part is deciding what variable to solve for. And this is kind of a trick question. There are 2 equations. Again, I'll call the top A, and I'll call the bottom B. And you notice, this time I would take the answer that you could solve A or B. And I would take the answer that you can solve A or B for Y. Now, since the bottom Y is positive, I find that to be easier to solve. If you solve the top one, you're going to have to divide by a negative. So I'm going to get what I'll call B prime. I'm going to solve B and get an equivalent equation to B. And it's going to be y equals negative 2x plus 25. And again, remember, we're prejudiced in math. We always put variables before numbers. We don't want to write 25 minus 2x. We want to write negative 2x plus 25. I'm going to put B prime into A. And I'm going to skip the step this time where I write y and erase it. Here's y. 4x minus y equals 41. But y is equivalent to negative 2x plus 25. We need to distribute the sign in the coefficient, which is 1. So negative 1 multiplies in. And we got to be really careful not to make math mistakes. Alright, and I get 6x. I'm going to add 25 to both sides. Equals 66. Ah! And again, divide by 6. X is 11. And I'm not going to be cute this time. B prime is easier. So I'm going to put 11 into B prime. Y equals. So B prime with X equals 11. And I'm going to get Y equals negative 22 plus 25. So y is 3. So my ordered pair is 11, 3. And again, I write it as an xy coordinate because it is an xy point. I'll plug it into A to check. Check in A. Because I used B. You cannot check it in the same equation. Check in A. 4 times 11 minus 3 equals 41. Alright, 44 minus 3. Is that 41? I think we've gone far enough. Every time you can check the answers. Every time you can be correct. I want you to look. I did it a little differently, and I thought I'd write it all out and walk it through faster. Same problem, right up here, A and B. But this time I decided to solve the second equation for x, which is a poor choice. It's not easy, it becomes a fraction. But here's what I want you to see, is that if you solve for b here, you can make b prime for x. And when you divide by 2, you end up with an equation with fractions. X equals negative 1/2 y plus 25 halves. And if I put b prime in A, instead of replacing y, I have to replace x. The point is it works out. 11/3 was the last answer. 11/3 here is the same answer. Numbers are numbers. Fractions are integers. We just want to take the easiest path if we can. It's not incorrect. This is just more difficult to do. Alright. What I want you to do on these two is give them a shot. Pause the video. Try them. The biggest thing, if you want to do the left one first, then the right one, the biggest thing is picking what variable to solve for at either A or B, X or Y in equation A or B. I look at the top one here and I say, man, definitely not B. It has coefficients that aren't 1. But when I look at the top, I say, hey, I can easily solve for X. And I can move 2y to the other side by adding 2y to both sides. And if I do that, I get x equals 2y minus 1. And now I have what I'll call A prime. Same as A. They're equivalents. Okay? And I'll cross that out because I did it now. Now I can put this into B. So 2 times 2y minus 1, because it was x. Alright, this cancels. 4y minus 3y is 1y, which I'll write as y. 4 plus 2 is 6. Y is 6. I'll put into A prime. I'll get x equals 2 times 6 minus 1. 12 minus 1 is 11. I will check in B. And the point I have is 11, 6. And I'm sure I'm right, I hope. I get 22 minus 9. Alright, 22 minus 9 is not 4. Well, that's because it's not 3 there. It's 6. How about 22 minus 18? It's 6 here. Alright, 22 minus 18. That is 4. Boom. And I've checked. On the second equation, we take a look at that one. And again, big numbers. Should you solve the top equation or the bottom equation? Which variable? I'd say the bottom. And again, I would say I want to solve for y. I'll move to x. And I will write y equals negative 2x plus 25. And again, I'll cross off that, and I'll have, hey, A. And I'm just going to call it B. It's the same. I just move some stuff to the other side, use my rules of equivalencies, do anything I want as long as I do it to both sides. And I will put B into A. B into A. I had 4x minus 2 times y equals 38, but now y is equivalent to negative 2x plus 25. And again, these numbers start to look the same. 4x plus 4x minus 50 equals 38. I'll add a nifty 50 to the other side, and I get 8x equals 88. Boy, oh boy, Mr. Anderson likes x's 11 today. I will put 11 into the other one. And if you didn't catch this, this is the same problem. Y is 3. If we check that into, and we used, here we use B, we have to check it with A. And I put it up there, I get 44 minus 6, And the question is 44 minus 6 38? If you check it on your calculator with some longhand math, the answer is yes, it is. And away you go. Again, this is equivalency. It's doing the same thing to both sides. And again, there's a single point where two lines will cross. Now, we haven't talked about parallel lines or lines that are skew. But right now, everything's going to cross, and they have a place where the value or the ordered pair makes both equations true. And that's what substitution will find for you. Keep practicing. It'll go well.